Today we're going to tackle our Chapter 3 assessment, atoms, elements, and the periodic table. In this very first section, it's asking us to test our concept knowledge. The directions say for each of the following, write the letter of the term or phrase that best completes the sentence. Mr. Shane is going to read for you the sentence and then read through the different options and show you which one of those would be the best answer to fill in that blank or to answer that question. Number one, a blank is a particle in an atom with a positive charge. Positive proton, that's going to be letter D. Number two, each of these is an example of matter except. Except means we're focusing on the one that is not matter. Cloud, made out of water and moisture, is matter. Beam of light, not matter. We'll come back to that one. Let's just see if it's an exception based on the other ones. A dust particle, made of matter, and air, made of matter. So B, beam of light, is going to be correct. Number three, an atom of the element with atomic number 6 always has 6 electron clouds, 6 protons in its nucleus, more than 6 neutrons, or an atomic mass of 6. Remember, the atomic number tells us the number of protons, so the connection would be right here to letter C. 6 protons, atomic number 6, 6 protons. Number 3 is C. Number 4, the atomic number of an element tells the number of blank in the nucleus. We just said that the atomic number 6 always has 6 protons. The atomic number of element tells the number of C protons. Sometimes you can use other questions to help you answer the next question or another question on your test. Number 5, Rutherford's experiment showed that most of an atom is made up of A, electron cloud, B, nucleus, C, alpha particles, or D, empty space. Well, in Rutherford's experiment, you've got to remember that they were launching alpha particles into this gold foil. Some of them bounced back, and the comparison was if you actually shot a cannon at a piece of tissue paper and it bounced back at you. Most of them went through, but some bounced back, which allowed him to discover the nucleus, but most of it was actually empty space, letter D. Number 6, isotopes of an element contain different numbers of blank. Isotopes is our key term here that we want to focus on. Different numbers of what? Electrons, neutrons, protons, or energy levels. Well, it can't be protons. We can eliminate that because any different number of protons is going to be a different element altogether. Isotope refers to the same type of element, but it's got a different number of B neutrons. 7, water is an example of a compound, a heterogeneous mixture, a homogeneous mixture, or an element. Now, to know the difference between these, you'd have to understand the periodic table, compounds, the difference between an element and a compound. An element is one type of atom. A compound is more than one type of atom. The difference between a homogeneous mixture and heterogeneous mixture, again, homogeneous means it's the same throughout, and the heterogeneous mixture means that it is different in different parts of it, like Chex Mix. Well, a couple of these answers might actually be correct because water might look like it's the same throughout, and it's made up of multiple elements, H2O, but which is the best answer between letters A and C? I'm going to say that it's a good example of A because of H2O being multiple elements in there. Even though it could be considered homogeneous, we're going to say A is a better answer in this case. 8, most elements found on the left-hand side of the periodic table are going to be metals. That was that big blue section in the back of our textbook. 9, air is an example of blank. A heterogeneous mixture, a compound, a substance, or a homogeneous mixture. Again, the difference between these two, these you can see the different parts, these you cannot see, they're the same throughout. Compound is more than one element, and substance is described as a pure substance if it's got only the same thing all the way inside of it or being contained inside of it. So for letter 9, our best bet is to call it a homogeneous mixture because air and gas in that state operate in a way in which all the things that are in it mix together in a uniform way. Number 10, Blank developed a model called the atomic theory of matter. Here's where you're going to have to remember back to lesson 1 in the historical aspect of the development of the theory of the atom itself. John Dalton, Ernest Rutherford, Democritus, or J.J. Thomson gets credit for the atomic theory of matter. Number 10 is letter A, Dalton's theory of matter. 11. During Chadwick's experiments, streams of blank were unaffected by an electric field. streams of alpha particles, neutrons, electrons, or protons. Here again with Chadwick, we had the cathode ray tube in which there's an electric charge going across from a negative to a positive, and when a magnet was introduced, there were different reactions to electrons and protons. Something that would not have a reaction or is unaffected because it doesn't have a charge would be B, a neutron. Number 12, a blank small particles that make up most types of matter on Earth. Compounds, elements, mixtures, atoms. When it says small particles, it's referring to not elements, but the even smaller version of that for number 12 would be D, atoms. You could make the argument that, well, small particles such as different types of elements that are really small or in small amounts, or compounds or mixtures, almost all of these answers could probably make this sentence somewhat correct, but the best answer for us is going to be letter D for number 12. Continuing with the multiple choice, 13 and 14. 13, matter that is not, notice it says not, it's got this capitalization right here to show you that this is something specifically that we're looking for in the question. Matter is not considered to be a single substance, is A compound, B element, C mixture, or D isotope. Here we're going to call not the same a mixture. 14, a property, again, not associated with metal, is A, electric conductivity, ductility. Remember, ductility is it's being able to pull into a wire. A lot of wires I know are actually made out of metal. They might be wrapped in some type of rubber or plastic coating so that you don't get electrocuted by them, but they're a lot of times made of metal. So electric conductivity, ductility, those don't really work. Shininess or brittleness. Shininess, most metals are shiny. That's why they have a lot of their value in terms of like jewelry, gold, and silver. Brittleness means that it's easy to break them. Metal is not very easy to break because it is malleable instead of brittle. So our best answer for number 14 is going to be letter D. Now the next section, let's take a look at the directions. 15 through 19 says, identify each statement as true or false. Rewrite false statements to make them correct. 15, matter is anything that you can see and that takes up space. It's not necessarily anything that you can see because there are a lot of things that are actually smaller than the human eye. So we're going to call that false. We're going to say matter is anything that's blank and takes up space. Anything that has mass. I'm going to put this little caret here. Has mass. I'm going to cross out this portion. Matter is anything that has mass and takes up space. Now it's correct. 16. Metalloids are elements that have characteristics of both metals and nonmetals. Metalloids fall right in between nonmetals and metals on the periodic table. That is going to be a true statement. 17. J.J. Thomson's experiment with cathode rays led to the discovery of the neutron. This would be false. If you refer back to our study here, Chadwick was given credit for discovering the neutron. So J.J. Thomson was using the same type of experiment. He was actually before Chadwick. He didn't discover the neutron, however. He discovered something that actually bent to the light. So what we're changing here is going to be the electron. I would cross this out. J.J. Thomson's experiment with cathode rays led to the discovery of the electron. Because he knows that that negative charge was affected by the magnet when it was introduced to that cathode ray tube and the charge being fired through it. 18. A compound with the formula C6H12O6 is made up of 3 atoms. 18 would be false. There are 3 different types of atoms. There's a carbon atom, there's hydrogen atoms, there's oxygen atoms, but these little subscripts down below we learned actually show us how many there are. So there are 6 carbons, 12 hydrogens, and 6 oxygens. If you add all those up, 6 plus 6 is 12, 12 and 12 is 24. Compound with the formula C6H12O6 is made up of, cross this out, plug this in, 24 different atoms. 3 different types of atoms or 3 elements. So carbon, hydrogen, and oxygen, a total of 24 atoms to make what would be a sugar molecule. 19. Fruit salad is an example of heterogeneous mixture. A salad is a good example of heterogeneous because you can see the different ingredients in it. If it's a fruit salad, you have different types of fruit that are added into it. So you might have strawberries, you might have pineapple, you might have grapes, you might have mango or some type of cantaloupe. That's going to show a fruit salad that is made up of different types of materials. Heterogeneous means different. That's going to give us a true statement. Now our understanding concept says making and using this table. Fill in the missing numbers in the table. You've got elements that are listed here, A, B, C, D, and E. It doesn't even give us what those elements' names are. You could look those up if you'd want to, because we would know what they are based on the number of protons. It tells us to fill in the missing blanks. So we've got a couple here in each of these problems. So 1, 2, 3, number 4 has 2 to fill in, number 5 has 3 to fill in. Now there's a mathematical way in which this can be calculated because some of these have relationships to each other. First thing that we're going to assume is that all of these elements are considered neutral. That means they've got the same number of protons and electrons, so they wouldn't have a different charge. The only thing that could be different would be the neutrons that would make an isotope of that element. So in number 1, you've got an element that has 3 protons and 4 neutrons. So you notice here's the difference between the number of neutrons, but the protons and electrons are exactly the same. The atomic number comes from the number of protons. So if this is here, I'm going to look all the way over to this section. These numbers should be exactly the same. If it is 3 here, I should have 3 there. Now remember our mass number. How do we get this 7? The 7 is actually adding up the number of protons and neutrons. So you would take number of protons and neutrons, and you're going to put that answer over here after you add those together. So take a look. This should be the same, 3 and 3. This one is 3 plus 4 equals 7. Okay? Number 2, letter B for our element, it has 2 protons, so the number of neutrons we don't know yet. It has 2 electrons, and its mass number is 4. So if I have 4 total, and 4 is in reverse order, 2 plus what equals 4? Well, 2 plus 2 equals 4. Remember, this column plus this column, so 2 plus 2 equals 4. Just like in the first one, 3 plus 4 added together equals 7. So sometimes you can use that kind of reverse addition or subtraction. In this case, 4 minus 2 would give you the missing number that you have here. In number 3, element C has 11 protons and 12 neutrons. If I add those two together, 11 plus 12 is going to give me a mass number of 23. So these two columns, 11, 12, added together, get 23 as our total here. The number of electrons then is always going to be based on the assumption that these elements are neutral. If you've got 11 protons, you should have 11 electrons. Number 4, element D, we don't know the number of protons and we don't know the atomic number. How are we going to figure out what this element is? Well, if it's got 6 electrons, you could assume that it's got 6 protons if it's neutral. Or we could do the math to say, well, the mass number is 12 and there's 6 neutrons. So if it's got to equal 12, 6 plus what equals 12? Well, that would be 6. 6 plus 6 equals 12. And there's 6 electrons, 6 protons. So 2 ways to tell that. The atomic number then is going to be the exact same as the protons. So if this is 6, this is 6. Notice how every one of these columns and these columns match up exactly. And then by adding these two, you actually get this last column here. In number 5, we've got element E. The number of protons is not listed. The number of neutrons is 18. The number of electrons is not listed, and the atomic number is not listed. We've got a couple different ways in which we can go about solving this. Because we have the mass number, we can work backwards again. We've got 35, which is the addition problem of something plus 18. So if I want to think about that mathematically, I can say, well, something plus 18 equals 35, or I could say, well, 35 minus 18 equals what to give me that missing value? Here I would cancel, turn this into a 15, and 18 is 7 and 1. That's 17. So this missing number is 17. 17 plus 18 is 35. If there are 17 protons, I know there are 17 electrons. If there are 17 protons, I know that I have the atomic number of 17. Now just checking on that again, number of protons equals the number of electrons because we've got a neutral atom. There's no difference in charge. Number of protons equals the atomic number because the atomic number is what indicates the number of protons, so this tells us what that value is. And then by adding these two, I get my third column, or my last column here, the mass number column. If I ever have one of these mass number values and I have one of the 2 protons or neutrons that are in the nucleus, I can do that subtraction that we just did here as an example to find what that missing value is. That's your test. Hopefully you followed along and that became something that you were really successful at. Thanks for watching.